So in this problem, the number X in thousands of cat flea collars demanded each year when the price of a collar is P dollars is expressed by this function, X cubed plus 250 P squared equals 17,000. Now notice that neither X nor P is solved explicitly for. They're both just a part of the equation. The collars are currently selling for $3 each and the annual number of sales is 24,000 and something. Find the approximate decrease in sales. Okay, and the number X is the number of demanded, which is the number of sales, okay, of the collar if the price of the collar is raised by $2. So what this is implying is that sales, or S, depends on the price P, okay? So X, what I'm hoping you get from this is that X depends on the price P because X is the amount demanded or the number of sales, which depends on the price, which makes logical sense. So X is a function of P, so what we want to find is the rate of change of X with respect to P in order to find the approximate decrease in sales depending on a certain change in price. So we want to find dx dp. So in order to do that, because P is not, or X is not explicitly solved for, and I don't really want to either, I'm going to take the derivative with respect to P of both sides of this equation to get X cubed plus 250P squared equals the derivative with respect to P of 17,000. So on the left here we get 3x squared times, that's by the chain rule, times the derivative of x with respect to p, dx dp, plus, now p is the independent variable, so when we differentiate 250p squared, we just get 500p to the first, and the derivative of a constant is 0. Now we want to find dx dp, so let's go ahead and solve for that. So we get 3x squared times dx dp is equal to negative 500p. And we can divide both sides by 3x squared to get dx dp equals negative 500p over 3x squared. Now it says find the approximate decrease in sales, that is how much is X going to drop, okay, on the collar if the price of each collar is raised by $2. And this is at the moment when collars are currently selling for $3 each. So currently the price is $3 each and the sales are this. We're going to plug in those two numbers for X and P to find the rate at which X is changing when the price is 3. Okay, so let's compare. So dx dp when price is 3 and sales, or X, is 20. Let's see, X is in thousands, so this would actually be 24.524. When X is 24.524, since X is in thousands, that means sales are this much. Okay, plugging those numbers in, we get negative 500 times 3 over 3 times X squared, so 24.524 squared. And let's see what we get for that number. We'll need to use a calculator for that. Okay, so we've got 24.524 squared in the denominator times 3. And I am going to add that to my memory, 1804. So I'm going to do negative 1500 divided by this number. So 1500, that's my numerator, divided by the 1804 number is negative 0.831, 0.83136 if you round, negative 0.83136. Okay, so that's the rate of change of X with respect to the price. So what that means is when price increases by 1, the sales drop by this much, and X is in thousands, so it's dropping by about 831 roughly sales total if you increase the price by 1. So if you increase price by 2, sales are going to drop by double that much. Okay, so let's go back to the calculator here and do a times 2. Okay, so sales are going to drop by roughly that much if your price increases by $2, and now X is in thousands, so let's multiply by 1,000, and we get, it depends on how you round here, 1662.7. I'm going to round to negative 1663. Okay, and actually you would enter it positively because it says the approximate decrease in sales is about that many collars.